Hello, Yizhuan. I'm going to make you this quick video to try to explain these three questions for you. So let's work with the first one here. All right. So this is a 95% confidence interval for the difference between the two means. So we don't know what the means are. Let's just pretend we have a mean 1 and we have a mean 2 from two different variables, all right? So there's the first mean, there's the second mean, and we don't know if they're equal or not. We're looking for a significant difference. But now there's the key word, difference between the two. So the null hypothesis states this. It states that there is no difference, right? This is how you write it, that the first mean equals the second mean. That's what the null states. And then the alternative hypothesis states this, that they are not equal, okay? So if we could disprove the null, in other words, if we could prove that the null is false, we could accept the alternative as true. So now just let's get back a little bit, back to the null hypothesis. So now, look, this is the same thing as this. So if I took the difference between these two, right, I use subtraction. According to the null, the difference should be 0, right? This is the same thing. These two are the same thing, right? I just used some algebra. So if we had a confidence interval up here, that we're pretty sure the difference between the two is between negative 6.19 and positive 9.25. Let's look at that on a number line. Pretend that's a straight number line there. Right? And this was 0, 1, 2, 3, 4, 5, 6, 7. This was negative 7. This is negative 6, etc., etc. And going this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. This is 9. So if we look at this difference here, right, negative 6.91, so that would be right about here. And the end is 9.25, and that would be right about here. So any number in this box is in that interval, okay? So the difference between the two, again, it's the difference between the two means, could be anywhere in here, and the null states that it's 0. So with this confidence interval of the difference of the two means, you would not reject the null because this is what it's saying, that the difference between the two means is 0, and 0 is in the confidence interval of the difference of the two means. Okay, that was kind of a little bit hard to do, but let me show you a faster, easier way. Let's do number 41. So here's our confidence interval. So I'm going to draw a number line. Right? There's 0, there's 1, there's 2, etc., etc. Going this way, negative 1, negative 2, negative 3, negative 4, etc., etc. Now we're here between, let me get a different color, maybe that'll help. So negative 3.16 is right about here. And negative 8.4 is right about there. So what this one is saying, number 41 is saying, this one, is the difference between the two means is somewhere between these two numbers. But you'll notice that 0 is not in this number. So this is not true here. Right? The means minus the means, this is not true because 0 is not in the confidence interval. So with this one, we would reject the null. Okay? Now the last one, I'm going to just give you the quick answer. So if 0 is in the confidence interval for the difference between the two means, you cannot reject the null. 0, 1, 2, -1, -2, etc., etc. So this one, it's roughly here to 0.078 here, right? So this is our confidence interval. And again, you'll notice that 0 is smack dab in the middle of it. So 0 is in the middle of this confidence interval, again, for the difference between the means. So this could be true, because that's what the null states. So it could be true here. So again, the short answer is if the confidence interval for the difference of the means, that's the weird one, is for the difference of the means, the confidence interval, if it contains a 0 in it, you do not reject the null. Okay? So I want to thank you for your interest. And don't worry about it. You're not going to be tested on this. But I figured I'd just show you how that works. All right. I will talk to you on Monday. I'll see you at the school. MGZ out.